Today our job is to figure out how we measure energy. So we talked about energy. We said that energy was the stuff that makes everything go. It comes in different forms, but how do we measure energy? So in our bubble map we made last time, one of the forms of energy was food energy. So here's a question you probably know the answer to. How do we measure the energy that we get from food? So if you've been to the grocery store, or perhaps you've been to Chick-fil-A or anywhere else, you'll see that they actually tell you how much energy you get. So here at Chick-fil-A, they've got a sandwich, the Spicy Deluxe, and it says it is 540 calories per sandwich. That is telling us the energy. 540 calories is how much energy it gives us. Here is a food label for some cereal, and it says it's 240 calories per serving. So a serving gives us 240 calories. So it turns out that energy is measured in calories. That's one way we can measure energy. So calories is usually how we measure heat and food energy. You might remember using calories in chemistry. The standard unit in physics for measuring energy is called a joule. So this calorie and joule we're going to use. There's some other ways to measure energy that aren't very common, at least unless you work in specific trades. And you don't need to memorize these and you don't need to write them down. I just want to show them to you. One is called an electron volt. So in chemistry and atomic physics, we use electron volts as a unit of energy. You might remember talking about things like ionization energy and binding energy back when you were in chemistry, and those are measured in electron volts. Another way to measure energy is a kilowatt hour. This is how much electrical energy we use. If you go to the electric meter outside your house and look at it, you'll see it is calibrated in units of kilowatt hours. So that's a unit of energy. If you have a grill or an air conditioner or a furnace, how much energy it transfers is measured in something called a BTU, which stands for British Thermal Unit. So my grill is 10,000 BTU. That's how much energy it turns from chemical stored energy in propane to heat energy. So 10,000 BTUs every hour. So there's lots of other units. There's things called ergs and weird units, but the two we're going to use are calories and joules. Calories because we're used to it and it kind of makes sense in our head. We know what 100 calories kind of is. And joules because that's what we use for doing calculations when we're in the metric system. So that's going to be the main one right there. So you need to know that a unit of energy is the joule and the calorie. So if you go outside your house and you find your little electric box here and you look at it closely, you will see that it tells you how much energy you're using. You can write it down today, you can write down what the meter says tomorrow, and the difference is how many kilowatt hours of energy you've used. Over here, this is a sticker from an air conditioner, and you can see right here, it says its capacity is 6,000 BTUs. That's how much energy, heat energy, it can take out of a room in 1 hour. So everything that uses energy generally posts how much energy it uses, or there's a label that tells you that. Okay. All right. If you go to Europe and you get a Twix bar or something, its energy is actually measured in kilojoules. So right here you see this is a food label from Europe, and it tells you that the energy is 460 kilojoules. Kilo means 1,000, so 460,000 joules. It also tells you how much fat and sugar and salt there are, but right there is the energy. And if the energy is zero, then that's not giving you any energy at all, like a bottle of water. Look it up. There is no energy in a bottle of water. It just hydrates you, but it doesn't give you any energy. You cannot live on water. Oh, this is a picture of my downstairs in my basement, a picture of my water heater, and it shows you right here the energy it takes to make it work. It's in BTUs per hour. That's what the H stands for. So 34,000 BTUs per hour. So it's about 3.5 times as powerful as my grill. All right, so In order to do some problem stuff, we have to know how to convert back and forth between calories and joules. So I'd like you to jot this down in your toolbox, please. If you have calories and you want to find joules, you're going to have to multiply by 4,186. So if you have a number in calories and you want a number in joules, you multiply by 4,186. What happens if you have it in joules and you would like to know what the energy is in calories? Well, then you divide by 4,186. So this is a fairly simple conversion, and we're going to solve some problems with it today. You just need to convert from calories to joules and from joules back to calories. All right? Okay, and that's what we're going to practice today. So the next thing for you to do is to solve some problems, converting from calories to joules and joules to calories. And then tomorrow, we're going to talk about kinetic and potential energy and how to calculate them, and we'll have to do some conversions there too. Okay? All right, good luck solving the problems. I'll be online during my office hours from 9 a.m. to 3 p.m., so you can check in anytime you get stuck and get help right away, okay?